Question 1a is just a matrix multiplication. So the way that you multiply matrices is you take the rows in the first one. So for example, this row that I'm highlighting in yellow, and then you take the columns in the second one, for example, this one, and then where those that row and that column overlap, that's where your entry is going to be. So you can see both of these have the top left entry. So that means when we multiply it out, this is going to give us the top left entry. So we take each individual part. So -1 multiplied by 5 gives us -5. And then 0 times 0 is obviously just 0. And then 2 times 2 is 4. So +0 plus 4, because of that 0 in the middle. And then -5 plus 4 equals -1. So you multiply each individual component and add them together, and that'll give us -1 in the top left. And you just do that for the rest of them then. So I'm not going to rewrite it out every time. I'll just go through it quickly. But I'll keep the highlight up to show what rows and columns I'm working with. So if we want to go for the top middle, we'd move the column over to the middle because we already have the row on the top. So move the column to the middle, and we get -1 times -1 is 1. Then 0 times 4 is 0. 2 times -1 is -2. So we have 1 minus 2 is -1 again. And then finally, we'll go to the right column. -1 times -2 is 2. 0, and then 0, because multiplied by 0. So we'll just get +2 as our result there. Now we'll move down to the middle row. And we'll go start over on the left again. 5 times 3 is 15. Then 1 times 0 is 0. -1 times 2 is -2. 15 minus 2 is 13. Go to the middle. 3 times -1 -3. 1 times 4 is 4. That gives us -3 plus 4 is 1. And then -1 times -1 is 1. 1 plus 1 is 2. And then finally, 3 times -2 is -6. 1 times 3 is 3. -1 times 0 is 0. So we have -6 plus 3 will give us -3. Then finally we do the bottom row. And we'll have 0 times 5 is 0. 2 times 0 is 0. And -3 times 2 is -6. Move to the middle. 0 times -1, 0. 2 times 4 is 8. And then we'll have +3. So we'll have 11. And then finally, go to the far right. And 0 times -2 is 0. 2 times 3 is 6. And -3 times 0 is 0. So we just get 6 here. And that's the answer for what AB is. Matrix A times B. Make sure that you don't accidentally multiply them the other way around, because matrix multiplication is not commutative. Part B then is finding the MST of a network. So it says to use an appropriate algorithm, find the tree, name it, and then show your work. So in terms of showing the work, it says at the start of the exam that you can give your answers on the given graphs, networks, or diagrams. Your work should be on those. So I would recommend that you do your work on the diagram to save time instead of drawing it all out again. So that's what I'm going to do here. And I'm going to use Prim's algorithm in the interest of time, which I'll explain in a second. So Prim's algorithm. And you can start anywhere. I'm just going to start at O because it says that O is her office, and that's the starting point. So starting at O. The reason I would opt for Prims over Kruskal's whenever I have the option is because for Kruskal's, you have to list out every edge in order. So, and first of all, obviously it's hard to scan the whole thing. So you might see this 21 and think that's the smallest. Then you list out the rest, and then you realize, oh wait, there was this 20 here, and then you have to go back and adjust it. At least for Prims, you only have to look at one part at a time. You only have to look at the kind of, like if I'm starting from O, I only have to look around O, so it's quicker. And I think it's also a little easier to show your workings out then as well. So it's just easier, it's quicker, and it's harder to mess up. So what we'll do is we'll start at O, and then we look for the smallest edge connected to O. So it's this 20 here. So what we'll do is we'll add this 20 to the graph. And to fully show your workings, if you have the time, I would suggest that you write out a little table saying here are the edges, and here are the weights. So edge OB, weights 20. Okay, and we added it to our network. Now we look at anything connected to this blue line. I'm just doing it in blue. I'd recommend that you do it in pencil probably first, because if you mess up and you accidentally scribble over one of these letters and numbers in pen, you obviously can't rub it out, and then you've lost the question. So probably do it in pencil first, and then do it in a blue pen to make it clear for the examiner. If you do it in a black pen, you might not be able to see it against these lines, so do it in a blue pen. And then red and green sometimes don't get scanned, so it's just blue. So now the smallest one connected to this 20 is this 45. So we will add AB, which is 45, and then just draw it in. Now the next smallest one is this 56 down here, going from O to C. So we'll write OC, and that's a weight of 56. Next smallest then is this 43, which is CE. So we'll have CE, which is a weight of 43. Next smallest one, so 62 is the next smallest one, but that would create a cycle, as you can see. So we're going to skip that. Then 71, that also creates a cycle, so we'll skip that. So next smallest is 73, which is AD. So AD, which is 73. And then the next smallest is DF with 27. So I'll write down DF, 27. And then it's 48 from F to G. Then it's 59 from G to J. Now you might be tempted to keep going and just say, well, 88 is the next smallest, but remember, it's anything connected to these blue things. So all of these are already connected. We don't have to look over here anymore, but we can see the 66 up here is the next smallest one. So D to H, that's 66. And our next smallest now is the 88 here from I to J. So we're at I, J, 88. Then we have IL for 21. And finally, we have KL, which is 40. And that's our minimum spanning tree now, finished, because we've connected all the nodes together. There's no more nodes to connect. And then in part 2, we're asked to calculate the shortest distance she would have to walk if she started at O and followed the minimum spanning tree to reach each of the camera locations. So this is actually quite interesting because there was a similar question last year, and what a lot of people, they didn't specify that it was the minimum distance they'd have to walk. So because of that, a lot of people just added up all the numbers and called it a day. So this year they very specifically specified how long they'd have to walk. So you have to think of this not just adding up all the numbers, but actually in terms of the spanning tree. So let's say you're starting at O and we need to visit all of these nodes. So obviously we want to visit C and E first, because once we go further, we can't really go back to C and E. So we'll start off by going to C and then to E, but then we also have to travel back. So then we go back to C and then back to O. So in reality, instead of writing 56 plus 43, since we end up doing that journey twice, we'll actually have 2 times 56 plus 43. And then we just continue on our little route. You don't have to draw these red lines, by the way. I'm just doing it to make it clear. Then we'll have plus 20, then plus 45, and then plus 73. And I'll just stop there. So plus 20, plus 45, plus 73. Because then... again, we don't want to go down here because then we're leaving out H and we'll have to come back. We may as well get H out of the way now and then go back to D, and then we can continue following the minimum spanning tree. Because remember, she has to follow the minimum spanning tree. So we'll have to do 2 times 66 because she walks from D to H and then back to D. So 2 times 66 plus, and then we have 27 plus 48. We just add the rest because the rest is a straight line. So you can see we'll have 27, 48, 59, 88, 21, and 40. And then we're at the end. We've now visited all of the cameras. So I need to add all those up. And when you add all those up, you should get 751. And then it says that these are all distances in meters. So make sure we write that 751 meters, just because sometimes they can be a bit picky with the units. So part C is a pretty tricky uniform motion question. So question 1 was a very long question and quite tricky. So we have this guy cycling a constant speed of velocity of 10, and he's 21 meters behind another cyclist, Kevin. And he's cycling at a constant speed of 4 meters per second, and they're going in the same direction. John accelerates at 2 meters per second squared, and 1 second later, Kevin accelerates at 4 meters per second squared. Calculate when they overtake. So I was kind of talking to people online, and there's a few different ways that people did this. I'm pretty sure this should be the right way, though, and the right answer. So basically, we have Kevin. This is the guy in front. So I'm going to use K to show him. Let's say where they overtake is at a point which we'll call D, okay? So we'll call it lowercase d, actually. So this distance here is D. So this distance here is D. And D is just when they overtake. It's some distance. We don't know what the distance is. We're just going to call it D for now. Now, John, he starts off 21 meters behind Kevin. So let's say this is John here, and this is an extra 21 meters. So that means the total distance that John has to travel is 21 plus D meters. So that's basically the setup that we have. So we're going to start off now. So for John, it's relatively straightforward. We'll set up our SUVAT. So the distance he has to travel is 21 plus d meters. His initial speed for John is 10. His final speed, we'll see, won't matter. His acceleration is 2 meters per second squared. And the time it takes him to get there is like t seconds, we'll say. Now for Kevin, it's a little bit harder because he is going at 4 meters per second, but then after 1 second, he begins to accelerate. So if he's traveling, since he's not accelerating, you can use speed is equals velocity times time. So, or sorry, not speed, displacement equals velocity times time. So the displacement he traveled was his velocity, which is 4, and he did that for 1 second. So 4 times 1, that means he did 4 meters in this first section. So what happens in the first second, let's just ignore John for a second. Kevin moves 4 meters closer to this point D. So now, instead of having to travel d meters, now he needs to travel d minus 4 meters, okay? And because 1 second has already passed, instead of him traveling the distance d in t seconds, we're calling it t seconds because we don't know how long it's going to take, instead of him traveling it in t seconds, since he's already spent a second traveling, the time that he has to travel the rest of the journey is t minus 1 seconds, okay? So, for Kevin now, we have SUVAT. The distance he has to travel now is d minus 4 meters because he's already done the first 4 meters and he only has to do d minus 4 now. His initial speed, it says, is 4 meters per second. His acceleration then at this point is going to be 4 meters per second squared. So Kevin begins to accelerate 4 meters per second squared. And the time that it takes him, it doesn't take him t seconds. It takes him t seconds from the very start, which is from when he was here. But now that 1 second is already gone, the time it's going to take him to get to the end is going to be t seconds minus 1 because we've already done 1 second. Now we can just set up our equation. So for John, we have, of course, we're going to use S. We have S, U, A, and T. So we'll use S equals UT plus a half AT squared. So we'll have 21 plus D equals UT will be 10T plus 2t squared over 2, or in other words, they cancel, and we just have plus t squared. We can solve for d, because we're going to have to sub it in. D will be t squared plus 10t minus 21. Okay? Because now, for Kevin, we know that d minus 4 is his distance, and he does that in ut, which is 4, t minus 1, plus a half, a, which is 4, and then t squared will be t minus 1, the whole thing squared. So, and we know we can replace this d with the this thing here for the simplification. So we'll have t squared plus 10t minus 21, and then we'll have minus 4 from this minus 4 equals 4t minus 4 plus a half times 4 is 2, and then t minus 1 squared will be t squared minus 2t plus 1. Okay, and now we can multiply that out, but first we'll see this minus 4 cancels with this minus 4, and we can bring that 4t to the other. Actually, we don't need to do that yet, because you'll see it'll cancel. T squared plus 10t minus 21 equals 4t, and now expand out the bracket, plus 2t squared minus 4t plus 2. We see this minus 4t and the 4t and minus 4t will cancel. I'm going to bring everything to the right side now because it's a quadratic. So we'll have t squared, and then bring the minus 10t now, and then we'll have plus 23 because 21 plus 2. Now we can just use the quadratic formula to solve this because there's no factors of 23. That will give you 10. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's just a good idea to write down the equation. So t will be minus 10 is just 10, plus or minus the square root of, and then we'll have b squared, which is 10 squared, minus 4 times 1 times 23, all over 2 times 1. So if you put the square root into your calculator, you'll get that to be 2 root 2. So we'll have equals 10 plus or minus 2 root 2 over 2, or in other words, that's 10 sorry, not 10. That's going to be 5 plus or minus root 2, because just divide the 2 into each of them. Now it does ask us for not the time, but the times when they overtake each other. So we're expecting 2 answers here, and you'll see we'll get them. So the first time will be 5 plus root 2, which if you put into your calculator to get seconds, you could say. And if you put that into your calculator to get a number on it, you'll get 5 plus root 2. You will get 6.41 seconds as your first answer. And then for your second answer, you'll get 5 minus root 2 seconds. Or just in case they were looking for a decimal on it, you can put that into your calculator and you will get 3.59 seconds to 2 decimal places. And that should be the correct answer there.